Hang on, can you hear now? Is that better? Can you hear now? Hopefully you can hear me now. It's supposed to put the sound on automatically for me, but it didn't. So yeah.
Can you hear now? Is that better?
Yeah, I can hear me. I can hear me now. Okay, sorry about that, everybody. I need that "you're on mute" sign. All right, so let's get going. Yeah, yesterday we looked at question 1 and paper question 1, question 2. So let's just move on to question 3, and we've got to write an algorithm in pseudocode using a single loop to output the average of 50 numbers that have been stored in the array number. Now, this has been used in previous exam papers, very similar sorts of questions. But basically, yeah, we need to write an array. So I'm going to go quiet for a moment and you can have a think about how to do this. And if you want to just give it a go, and I will go through the answer in a minute. Hi there. Yeah, we're just doing this question. You finally got the chat to work. Well done. Excellent. Good. So we're just doing this question here. Write an algorithm in pseudocode using a single loop to output the average of 50 numbers that have been stored in an array. So if you've done my lessons with me, then you'll know that averaging is one of the main algorithms that they want you to know. Okay, so you had an anti-recommendation extension which was preventing live chat, fair enough. All right, so don't worry if you're a bit stuck. Remember with averaging, you're adding everything up, so you're getting a total, and then you're going to divide that by how many there are, which is 50. So if I go to my, somewhere under here, I've got a, yeah, there we go. And we'll do it in pseudocode. Let's just get rid of that whiteboard there. Oh, put it over there. Okay. So this is 8th of Jan. There we go. Let's put that on. Yeah, so all we're doing is we're adding everything up in that array, and then we're going to divide by how many there are. And the first thing we need to do, though, when we're doing that is we need to create a variable. I'm going to call it total, and we set it to be 0 because this is going to have our sum. Now, we can use any kind of loop. It's up to you. But because we've got a set number, which is 50, I would always go for a for loop. So I'm going to go for a for loop. So I'm going to say for counter 1 to 50. And then I'm going to add all the items up in my array. So to sort of add that onto my total. So this is the summing part. So the total equals the total plus, and then this is where we use the array number, but it's not a number. For the reference here, we use the counter. And I'll talk about this in a moment again. I'll go through it. And then we just have next counter. So it's quite simple loop actually, or next counter. And that does the summing. And then the last bit is we need to get the average. So we create a new variable called average, and that is the total divided by 50. And then we can just output that. Output, the average is and then average. So there's just a few things to note here. I know some of you, lots of you don't like pseudocode. Just stick to these live streams. You'll get there, I promise you. Remember that all of the keywords, they're just the same as they are in Python, but they're just capitalized. And we don't have range in pseudocode. So actually what we do is we use the arrow 1 to 50. And we're just using the arrow. Remember, in pseudocode, instead of equals in Python, we use the arrow to set a variable. And we just have next counter or next, whatever variable name you call it, there as well. But otherwise, it's just very, very similar. We still use square brackets as well. So that's the sort of thing that they're after. Yes, you could use a while loop, but, you know, like I said, you're better off using a for loop. So how many marks was for that one? It was 5 marks for that. So if we just have a look at the answer, very sort of similar sort of questions that they have. If we just look at the answer, 1 mark for initializing total, 1 mark for appropriate loop control. So again, they haven't said which loop they want you to do, and that's up to you. Total statement inside the loop must use the array. Calculation of the average outside the loop, output the average outside of the loop. Okay. So yeah, knowing averaging, minimum, maximum, averaging, totaling, minimum, maximum, those 4 algorithms get you a long way in this exam. Okay, let's look at the next question. Describe the purpose of test data. Include an example of a type of test data in your answer. So why do we use test data? So it's basically 2 marks for the description and 1 mark for an example. What do you suggest we do while watching lessons? Try and answer the questions if you can. If you can't, just look for the answer. You can handwrite them, or even if you're just thinking what the answer might be, that will help as well. So give me a description. You can put the answer in the chat if you want to. You don't have to though. It's totally up to you. Don't put it in the chat if you don't want to, but do try and answer the question. Yeah, good. That's a really good answer there. Yeah, that would get you 2 marks for that. Good. Yeah, we use test data to predict and test the code we're trying to test while trying to get accurate results. An example could be 43, 5, etc. Yeah. So when they talk about example though, they're not after an exact amount. They're after the categories. Okay. So the categories of test data, you might remember from the lessons. So the category, will come back to test data, but remember the categories are normal, erroneous, abnormal, extreme, and boundary. So that's what they're after. But you can give a number as well if you did that. And then description of testing, checking that the program works as expected, check for logic or runtime errors, check that the program rejects any invalid input, checks that the program only accepts reasonable data. And then we can say normal, abnormal, erroneous, extreme, boundary. Erroneous is the same as abnormal actually, and they used to use erroneous in the previous syllabus. So this is kind of a bit of a hangover from that. And this is the first exam paper for 2023. So yeah, it's a bit of a hangover from that one. Okay, next question then. Describe how variables and constants are used in programming. So describe how variables and constants are used in programming. And there's 3 marks for this. So what you can do for this question is you can say, what, that's okay. If you put examples for that, that's fine. This is why we're doing the past exam papers, so you can see that what they're actually after. Okay, 3 things about constants and variables. What are they doing the same thing? How are they different? 3 things that are different or the same. They do like to, just going back to test data, they do love to, there will be a question on test data in the exam, I guarantee it. And if there isn't, I will eat my hat. I'll just make sure it's made out of wafer. Okay, so the thing about variables and constants is, variables can change. That's why they're called vary. It means they can vary. Constants cannot change once the program's running. In fact, I was looking at, what language was it? Was it Go? I think it was. There's a new language called Go, or Golang or something like that. And all variables in that are actually constants unless you say it's a variable. So they default to being a constant. Anyway, so what are they looking for this? Well, variables and constants are used to store items of data. So that's the only thing that they've got in common, really, other than the fact we've got to name them. So we give them a name or identifier. The value of a variable may change during execution of the program, but a constant will remain the same. Yeah, good. So don't forget, although they are different, they do have similarities, so you can always put that as an answer. Okay, next question then. I think I used this one in one of my lessons. So this is a structure diagram. Remember, a structure diagram is a bit like a sort of family tree type thing. And we've got a food ordering system. It's an example of a computer system that is made up of subsystems. And the food ordering system allows the user to enter the details of the food they want to order and pay for the order. Then we need to display the food available as pictures or a list. So you might need a pen and paper or pencil and paper for this. You need to complete the structure diagram. Basically, those 2 bullet points need to be put in it. So, I mean, the likelihood of getting this is, getting a structured diagram question in the exam is fairly low, but it could happen. It could happen. All right, so for this question, I'm going to go back to my writing pad here, my whiteboard, sorry. And what do we got? Well, we've got our food ordering system. So some of you might remember this from the lesson. food ordering system. And we've got 2 bullet points. We've got allows the user to enter the details, or we're displaying it. And this is pretty much, whenever you get something like this, it's very similar. One's inputting, one's displaying. So it's input, output, because that's all computer systems do, isn't it? So yeah, so one is kind of inputting, user input, and then the other one is displaying food. And then inside the user input, what have we got? We're going to enter the details for the food they want to order and pay for the order. So we've got food order, and we've also got payment. And then on the display, we've got it as pictures or a list. So picture and a list. So it's quite simple, really. You put input and output. Yeah, that's good. Yeah. Yeah, good. Okay. If we look at the official answer, well, the official answer is, or the marks that we're after, 1 mark for a suitable hierarchical structure, 1 mark for suitable names of the subsystem. So again, yeah, we've got suitable names, 1 mark for inputs, and then 1 mark for display. You don't, I mean, they've got display choice, but that's in brackets. You don't need that. I'm not quite sure why they put display choice there. Anyway. Okay, so that is a structure diagram. They are very similar. It's unlikely that you'll get one, but it might happen. Okay, so now we have got errors in code question. This one has got 3 errors. Normally they have 4. This one's only got 3. So the energy efficiency of an electrical appliance is the percentage of useful energy out compared with total energy in. An algorithm has been written in pseudocode to calculate the energy efficiency of an appliance. Values for total energy in and useful energy out are input. The efficiency is calculated and output as a percentage. The entry of the number -1 for either value stops the algorithm. So we've got repeat until, and we've got some code in between. There are 3 errors. You've got to suggest corrections. So see if you can find the errors. So someone said line 6 should remove the statement. Not quite. There is an error on line 6 though. So in fact, what I'll do is I'll give you all a bit of a clue. The line numbers are where the errors are 5, 6 and 11. So 5, 6 and 11 at the bottom as well. Yeah, I'll show the answers in a minute, yeah. Not quite the end, but that's a good guess though. That's a good guess. All right, so let's have a look at this. So the way that and I'll show you the way that I approach it. So I'm just going to I'm going to put this onto here, onto the whiteboard. Where is it? There it is. Okay. So the way that I do this is I block off the code and, or I don't use that one because that one, what's that doing? Go away. Oh, don't like that box. How do I delete it? There we go. I block off the code. We've got, although we've got a repeat until here, and we've got an if and an end if. But as I've already said, the errors are on lines 5, 6 and 11. Okay. 5, 6 and 11. But the way that I approach it is I start with the first line. We've got a repeat. Always check at the bottom, is it the correct structure? And we can check the statement of what we're checking as well. But it is a repeat until, so that is correct. And actually we can check line 10. We've got if and end if. That looks correct as well. I don't know if that's big enough for you. I'll make that a bit bigger for you. Yeah, that looks good. So that looks okay for now. But yeah, so we're checking total energy in is not equal to -1 or useful energy out is not equal to 1. And it actually says total values for total energy in and useful energy out are input. The efficiency is calculated and output as percentage. The entry of the number -1 stops the algorithm. So what are we using for -1? Input, total energy in, useful energy out. So is total energy in equal to not equal to -1 or useful energy out not equal to -1? So this is the main problem with that is it should be, instead of not equal to -1, it should be equal to -1. So it's the wrong logic. So both of those should be equals instead of not equals, because we're looking to see, are they equal to -1? Someone's asked, is indentation necessary in pseudocode? Yes, absolutely, 100%. You must indent it. It's got this, but it's the same rules as Python. So just think, what would I do in Python? And that's what you do in pseudocode. So yeah, so that's the first one. That the entry of -1 for either value stops the algorithm, and it was checking for not equal to -1 instead of equal to -1. And then yeah, so line number 5. We've got output, input, output, but that should be input because it is getting a number instead of inputting it. And then the last one is on the if statement. So basically we've got if the total energy in is not equal to -1 and useful energy out is not equal to -1, which is what we had in our repeat until, but it should actually be total energy in is not equal to 1 and useful energy out. So they've just basically misspelt. They had useful energy instead of useful energy out. So it's just using the wrong variable name. So although it did look quite complicated to start with, actually wasn't actually, you know, the errors were fairly basic really, if you see what I mean. So the next question is all about the same algorithm, but it's asking us to write pseudocode to check for an efficiency of 92% or over for this appliance and output A rated if the efficiency is over 92% or over. So we don't need to worry about where we're going to put it. We're just going to write the pseudocode. See if you can write that. What do you use if you're checking something? If. So a bit of a clue here. It's going to be an if statement. You thought input was on line 4. Yeah, but we need to input two things. So we're inputting the total energy in, and we also need to input the total energy out. So we're getting both of them. And that second one was outputting instead of inputting. So we don't have to worry about where this goes. We're just writing pseudocode. I'll give you a clue. It's an if statement to see if something's 92% or over. And if it is, print out A rated. Yeah, good. So some really good answers there. No, excellent. Yeah. So it is just a really nice, straightforward if statement. So we're just going to say if, and it is efficiency. So what's our variable for that? Efficiency variable there. If efficiency sorry, I spelled that incorrectly, is greater than or equal to 92, then output A rated, and then end if, and that's it. Nice, easy, 2 marks for just a straightforward if statement. Yeah. Okay, so let's logic gates. Excellent. So you might need to get a pen for this again because we're doing a circuit. We've got a logic expression. A or not B, and B and not C. And are we doing the... Oh, we are. We're going to do the truth table afterwards as well. So do both. I want you to do... Obviously, you're not going to be able to show me your circuit, but I'll draw it in a minute. Do the circuit and then do the truth table. We'll do the circuit first though, and I'll show you how to do the circuit in a moment. If you haven't done them for a while, I'll put this on the whiteboard. It will magically appear. There we go. Okay, there is our logic circuit. Is that long enough, everybody? Or do you need a bit longer? Okay, so I'm gonna do this. So we always think about what is going to be our central gate, because there's only ever one gate that leads out of that X, okay? And that central gate will never be in brackets. So we can see that this AND gate here is not in brackets, so that's going to be our central gate. You sometimes, very occasionally, they might have outer brackets like this, but we can just do, the same in maths where we eliminate brackets. But that AND gate, anyway, is our central gate. So this is going to go here. That's our AND gate, our central gate. I'm going to write on it. And then we've got two sides, or two wires coming out of that. We've got side 1, side 2. So this is side 1 here. And this one is going to be side 2. So we take each one. We've done the middle AND. We take each expression. We've got A or not B. So the central gate for that expression is the OR gate. So I'm going to draw an OR gate here. There's my OR gate. And coming into that is A. So I'll just draw a line from A and not B. So all that means is we go from B, and before it goes into that OR gate, then we draw a NOT gate. And then on the other side, so we've done those two, we've got B and not C. So this time the AND gate is the central gate. So I'm going to draw that there. I'm going to write on it as well. And coming into that is B on one side, and then not C. So here is C, so we just put not C there. And that is our circuit, and that's 4 marks for that. And, or is it 5 marks? Sorry, it's 5 marks for that one, so it's 1 for each gate. Good sanity check is to just count how many gates are in the expression. So we can see that there is 1, 2, 3, 4, 5. And normally, however many gates, that's how many marks you get. And we've got 1, 2, 3, 4, 5 gates on the diagram. So that's a good sanity check to do. Obviously, it doesn't guarantee you're going to get the marks because if you've drawn them incorrectly. But overall, we should get that correct. Okay, so that is our circuit. But now we need to do the truth table for this. So I'll leave that up here, and then I'll get the question sheet here, and then to remind you of the zeros and the ones, and see if you can do the truth table for this. And I'll go through the truth table in a moment as well. I'll see if I can get these on the same. Can I get them on the same screen? Yeah, that's pretty much not bad. And then this will be our final question for today. Yeah, so those of you giving answers, that looks good. That is correct answers. Good. Yeah, a bit of a weird one, this one. I'll just prep it so that I'll do it here actually. I'll do it underneath, see if I can get it printing out. Get a screenshot. Okay. So the key for doing these is to take each gate one at a time and don't worry about the rest of it when you're doing it. Okay. So I'll use a different colour. Is that going to be too dark? I'll use blue. Instead of starting from the X end or the output end, you need to start from the input end. And I'm just going to label everything. So I've got not B, I've got not C. So I'm going to start with those in a moment. And then I'm going to label the other ones D and E. So I've got not A first, not B and not C. Sorry, that's not C. So I'm going to do not B and not C. And then we've got D and E. So not B, all we do with this one here is we ignore everything else and we're just going to take the B column, ignore A, ignore C, and we take B and we write the opposite of it in not B. So we've got a 0, so we write a 1. We've got a 0, we write a 1. We've got a 1, we write a 0, a 1, a 0, a 0, a 1, a 0, a 1, a 1, a 0, and a 1, a 0. And we do the same with not C. So we just need to ignore everything else. We just look at the C column. So for the not C, look at the C column only and copy the opposite of each row into the not C. So we've got a 0, that's a 1, that's a 0, 0, that's a 1, 1, 0. So they're basically opposite each one like that. So we've done those two. It doesn't matter which order we do D and E. I'll just do D because it comes first in the alphabet. So I've got A or not B. So I'm just going to take A column and then the not B column here, and we're going to OR them together. So remember with OR, if any inputs are a 1, then the output is a 1. So we're just ignoring B, we're ignoring C. So A or not B, I've got a 1, a 1, a 0, 0, 1, 1, 1, 1. And then with E, we're ANDing together B and not C. So B and not C. So we can ignore everything else. Ignore C. So we've got B and not C. So they both have to be 0, a 1 for a 1 output. So that's a 0, a 0, a 1, a 0, a 0, 0, 1, and a 0. And then the final AND is D and E ANDed together. So the only thing we're looking for is where they're both a 1, and that's this one here. And then everything else is a 0 because it has a 0. Remember, with AND, they both have to be 1 for an output. Okay, so we've run over it. Oh, we're almost out of time. Well, that's pretty much it, actually. So I hope that's been helpful today. I'll see you next Wednesday night for the next one. And what paper is this? This is 2023 February, March 2023. There's only one paper for each in this sitting because it's the one for India. And you can find that in all my resources for the in the revision pack that I've given you. In that link, all the papers are in there, and you can download it. We'll continue with this paper. The next one, actually, the next question coming up in this is a trace table question. So if you wanted to give that a go before we come back on Wednesday, feel free. It's this one here. That's what we're going to be doing next. Okay.